Okay, here we go. What do we know? Dun, dun, dun. Function circle. Okay, so the image of the circle, centre 0, radius 2 in the z-plane is a line. Okay, so the thing we know about is z. Okay, so we know that we are starting with a circle here, and we're trying to show that we're going to end up with a line, but we don't know what the line is. So how could I write this circle? I've got two options. X squared plus y squared equals 4. That's one option. Or loci z minus 0, centre 0, equals 2. Or easier, mod z is 2. You've probably got the idea that this loci one is going to be easier. So let's start with that one and then take on the challenge of the other one. Okay, so what we're going to do, we're going to sub in z equals. Now this requires a bit of work. Let's do our work. W is 1 over 2 minus z. Notice I'm crossing my z's so that they don't get muddled up. So 2 minus z, muddled up with 2's that is, because 2's look like z's, equals 1 over w. So z equals 2 minus 1 over w. Okay, that's the work done. Can sub that in now. So 2 minus 1 over w modulus equals 2. Okay, let's fiddle around with it. So 2w minus 1 all over w modulus equals 2. Modulus of the top over modulus of the bottom times both sides by the bottom equals 2w. Do I recognise it yet? No, I need to get that 2 out. Don't like that 2 there. So that will be 2w minus a half modulus, but the modulus of a product is the product of the moduluses, so that's mod 2 mod w minus half. Mod 2 is 2, because the distance of 2 from the origin is 2, so that 2 cancels that 2, leaving me with, now I recognise it. This is the perpendicular bisector of the point and a half and the origin. So the point and a half is here, the origin is here, it's the perpendicular bisector of the two. It's this line here, which would be, don't forget we're now on the W plane, so this is the line U equals 1/4. So that's the equation of the line, and there's a little sketch of it. Okay, I'm going to try it the other way because I'm brave. Right, what do we know about? We know about Z. We know about the Z plane. So we start by writing Z equals. Oh, I've rubbed out the work. I'll have to do it again. W is 1 over 2 minus Z. Sorry, this will be boring for you. You can skip this bit because you've already done it. 1 over W is 2 minus Z. So Z equals 2 minus 1 over W. Okay, so Z is 2 minus 1 over W. Now we need component form. So we're going to sub in U plus IV, and then we're going to realise that denominator by multiplying top and bottom by the conjugate of the bottom. And then we're going to try and get it into its real and imaginary parts. So we've got U over U squared plus V squared, and this is in brackets, don't forget, so that minus and that minus make a plus. IV over U squared plus V squared. So this is our real part, and this is our imaginary part, and Z is X plus IY, so Z is X plus IY, and I'm just aware of what I'm going to sub this into, and I'm starting to think that maybe I'm going to abandon it. Okay, let me just see what happens. X plus IY, this is X. So what do we know? We know that X squared plus y squared equals 4. Am I brave enough to do this? Do you know what? Yes, I am brave enough to do this, particularly because I know it's going to come out to be a line. So things must cancel. I think this is just going to be fun. I'll clear some space. Okay, if you fancy it, you should pause the video and try this yourself just for fun. Because it's only algebra now, isn't it? We can do this. Okay, 4 minus 2 minus 4 lots of that, because 2 and another 2, and then plus U squared over u squared plus v squared squared. There's the first bit. Plus. Is that right? Yes. Okay, plus. What am I doing now? Squaring this. Oh, that's easy. U squared plus v squared squared equals 4. So if I times top and bottom of this one by u squared plus v squared, I could times through by u squared plus v squared. So I'd get 4u squared plus v squared squared minus 4u squared. I still don't have faith. I kind of do, but it just looks so horrible. Squared. Okay. Oh! Okay, that was good. Right. They cancel. What else can we do? U squared plus v squared minus, oh dear, 4u cubed minus 4u. Oh dear. No, it's okay, I thought of something. I think that was a bad move, expanding it out. I think that was a bad idea. Let's not do that. How about this? U squared plus v squared equals 4u squared plus v squared. And then divide both sides by u squared plus v squared. So 1 equals 4u, so u equals 1/4. Is that what I got last time? Yes, it is! Hooray! That was fun. Let's do another one.